Hello, community. Today we evaluate more than a dozen LLM systems on reasoning. So here, as you can see, we start with Llama, Claude, Dolly, GPT, Guanaco, Koala, MPT, Palm from Google, and then some non-transformer, Vicuna, Wizard. We have a look which is the best AI in logical reasoning. And we have a very simple benchmark question. More or less it is about, hey, what is the best way to leave Earth's orbit? Now let's compare our AI system. We go here to our benchmark browser and we have here the model A. This is a Llama 2, 70 billion chat optimized Llama 2 model. And the model B is a Llama 2, 13 billion optimized chat model. And the question is easy. Consider a satellite that is in a circular orbit around the Earth. The speed of the satellite decreases, so the speed goes down. What will happen to the satellite's orbital radius and the period of revolution? Please justify your answer using the principle of physics. And you say, yeah, physics, finally. So, you trust AI, so let's see how you can find your path to Mars. Now, Llama 70b tells us, hey, if the speed decreases, the satellite will experience a decrease in the centripetal force, which is the force that keeps it in orbit. The satellite will begin to move away from the center of the Earth, causing its orbital radius to increase. This can be understood by considering the energy of the satellite's kinetic energy, which is the energy of motion, is determined by its velocity, yes. As the satellite velocity decreases, its kinetic energy decreases. And since the satellite is in a circular orbit, its potential energy, which is the energy of position, is constant. Therefore, argues Llama 2, the total energy of the satellite remains constant. Interesting. And the satellite will move to a higher orbit where the kinetic energy is lower to conserve energy. This explanation is based on the principle of physics, especially Newton's law of motion and Kepler's laws of planetary motion. So here, if you trust Llama 2 with this explanation of a kinetic energy and a potential energy, under the assumption that we have here a constant energy, if the kinetic energy goes down, therefore the potential energy goes up, therefore the satellite will move to a higher orbit if you decrease its velocity. But now you choose another model. You choose Llama 2, but this medium, the 13 billion chat optimized version says, hello, I'm here to help you. And it says, let's consider the principle of physics that govern the motion of a satellite in a circular orbit around Earth. Nice. Satellite's motion is determined by the gravitational force exerted by Earth, and the satellite's velocity and radius of the orbit that are given by this equation. Now, if the satellite's speed decreases, we can expect its orbital radius to increase. This is, and now the explanation, because the gravitational force exerted by the Earth on the satellite is inverse proportional to the square of the velocity. As the velocity decreases, the gravitational forces decreases, causing the satellite to move further away from the center of Earth. So, gravitational forces decrease, moves away from the center of the Earth. Beautiful. Now, there is some follow-up question, and there was asked here, can you explain it further? And it's really interesting, but let me just focus here on this one. In my solution, there are a few corner cases or edge cases that need to be considered. What if the satellite speed is 0? Second, what if the Earth is not a perfect sphere? Okay. What if the satellite is not in a circular orbit? Okay. What if the satellite is in a highly eccentric orbit? An ellipse, for example. So, interesting. But we focus here, if you are the commander of this spaceship on the way to Mars, now you know you have to reduce your velocity in the orbit around Earth and you will increase here your position away from the surface of Earth. Beautiful. Now, let's go with the 7 billion model here. And we are here with Llama 2, the 7 billion chat parameters. Hey, thank you for asking. I'm here to help you with your question and we move you safely to Mars. So, to answer your question, I as Llama 2, 7b, we need to consider the principle of physics, check, that govern the motion of a satellite in orbit around Earth, check. The satellite speed decreasing will affect its orbital radius, check. And now comes the argumentation. According to Kepler's second law of planetary motion, the orbital radius of a satellite is directly proportional to its speed. This means that if the satellite speed decreases, its orbital radius will also decrease. So now here in the training dataset, Llama 2 learned that we have here a directly proportional relation between two parameters. And therefore, to summarize, if the speed of a satellite in a circular orbit around planet Earth decreases, its orbital radius will also decrease. So it will fall back to Earth if we reduce the velocity. This is in direct contradiction to Llama 2 70b. The total energy of the satellite remains constant and the satellite will move to a higher orbit. So the satellite will move out in space and not crash back on Earth. So as a pilot of your spaceship to Mars, I would say be careful if you go with the Llama 2 70 billion or the Llama 2 7 billion model. But you know, what is correct? Now, hey, no problem. Let's go to Alpaca. So here we have Alpaca. An Alpaca 13b, another size. Hey, if the speed of the satellite decreases, its orbital radius will increase. This is because the satellite is moving in a circular path, and the decrease in speed will cause it to move further away from the center of Earth, resulting in an increase in its orbital radius. Great. So Alpaca 13b agrees with Llama 2 70b. And you say, okay, let's go with Claude. Let's give Claude here something. So let's have a look at this. Claude says, if the speed of the satellite decreases, then the orbital radius will increase. Wow. This is because for a circular orbit, the satellite speed is related to its orbital radius by Kepler's second law. The period, yeah. In summary, if a satellite in circular orbit decreases the speed, its orbital radius and the period of revolution will both increase. Argumentation, Kepler's second law of planetary motion, and the conservation of angular momentum of a physical subsystem. Okay, so now we have a new component. We have suddenly angular momentum in our physical description. Hope this helps to clarify the physical principle. So, Claude agrees with Llama 2 70b, but gives a different explanation because here we are talking about angular momentum. And you say, no problem at all. Yay, Claude without instant. Okay, let's have a look at Claude. If the speed of the satellite decreases, the orbital radius will decrease. What? Suddenly we will crash back into Earth? But Claude Instant just gave us the complete opposite answer. Gee, I don't want to be the captain of this spaceship on the way to Mars because now you have to decide. But okay. So Claude and Claude Instant, completely different message. Hey, what do you think about Dolly? Dolly was such a nice version here. Come on, let's have a look at Dolly. The orbital radius of the satellite will decrease, so we will crash into Earth. Because of the orbital speed is decreasing and according to the conservation of energy, the kinetic energy is equal to the potential energy if we have equilibrium. Thus, the orbital radius will decrease and the period of revolution will increase. Now, you have here the same logical path in the argumentation as in Llama 2 70b. You have here the kinetic energy, satellite's kinetic energy, and you have here the potential energy. But now suddenly, although it is the same reasoning path, we have the complete opposite result. Interesting. So I'm so glad that AI, you trust AI here with your financial data, you trust AI with your private email conversation, and you trust AI with your banking and investments. So great. Okay, let's go to a heavy model, Falcon 40B. What is the reasoning path with Falcon 40B instruct? If the speed of the satellite decreases, which means that its kinetic energy decreases, according to the law of conservation of energy, the total energy of the system, the system is now the satellite and the Earth, remains constant. Therefore, and I'm really interested in the result, the energy lost by the satellite must be gained by Earth. So we have suddenly here the perspective of a two-body system, okay, that is coupled. This energy gain will cause the Earth to move away from the satellite. Speechless. So the Earth will move away from the satellite. Yeah, okay. Falcon 40B, which will increase the distance. If the Earth it moves away from the satellite, then it's the increase in the distance. Okay, so this will increase the distance, will cause the satellite's orbital radius to decrease. So if I put a two-body system further apart to increase the distance between those two bodies, the radius of a satellite will decrease. Wow, there's so much to talk about here, but we are looking not at the theoretical physics implications here of this AI advice for your spaceflight to Mars, because we have here... Okay, should we go to... Yeah, we go to ChatGPT. ChatGPT. If the speed of a satellite in a circular orbit around the beautiful planet of Earth decreases, a satellite will move to a lower orbit with a smaller radius. Now the logical argumentation, because the gravitational forces between Earth and the satellite is still present, yes, okay, and the force is proportional to the mass of the Earth, the mass of the satellite, correct, and inverse proportional to the square of the distance between them. Really? Therefore, as ChatGPT argues, if the speed of the satellite decreases, the gravitational force will put the satellite closer to the Earth, and the radius of the orbit will decrease. So, I think Llama 270B and ChatGPT completely disagree. But hey, you, as a pilot of the spaceship, don't worry, I have GPT-4 for you. But before we go to GPT-4, we have so much more. Let's go to a 65 billion parameter model. Yippee, yippee, yay. So, Guanaco 65 billion free trainable parameter tells us, listen, if the speed of this satellite decreases, it will experience a gravitational force from Earth that will cause it to move towards the Earth's surfaces. This means that the satellite's orbital radius will decrease, so we will crash into Earth if we break. Okay. In summary, if the speed of the satellite decreases, its orbital radius will decrease. You see, still a contradiction with the Llama model, but hey, never mind. Let's go with Llama 1. Yeah, let's see if Llama 1 has one sentence. Llama 1, one sentence. The satellite's orbital radius will increase. Yeah, Llama 1 and Llama 2 70B agree. Hey, we have here an agreement between two AI systems, one completely out of date. Okay, do you see a pattern? So, MPT instruct is important, so, wow, here we go. MPT instruct. Since the speed of the satellite is decreasing, the satellite is experiencing a centripetal force that is not constant. This means that the satellite will not follow a circular orbit, but will instead move towards the center of the Earth, so crash in the Earth. As the distance between the satellite and the center of the Earth decreases, the orbital radius will decrease. This is a true statement, but just between the sentence part 1 and the sentence part 2. Everything else is still open to investigation. Wow. Okay. Amazing. Amazing. And you know, there are just two solutions. We are increasing the orbit, or we are crashing back. Now, imagine you would have an investment decision where you have multiple options in multiple timescales with multiple behavior. No, come on, we are here. Yeah. So what else we have? Pythia. Yeah, Pythia. Why not Pythia? Let's have a look at this. As the speed of the satellite decreases, its orbital radius will also decrease. Ah, interesting. This is because the satellite is now taking longer to complete one revolution around the Earth. This is because the satellite is still orbiting at the same speed, but the speed of the satellite decreases. Okay, we continue. Palm. Hey, Google, Palm 2. Ladies and gentlemen, and now the official answer by Google is the satellite's orbital radius will increase. This is because the satellite's centripetal forces is provided by gravity, and the centripetal force is proportional to the square of the orbital radius. So if the satellite's speed decreases, the orbital radius will increase in order to maintain the same centripetal force. So now we're not talking about anymore in the energy picture, but now we are talking here in forces, in a parallelogram of forces, where forces stay more or less constant. Okay, a centripetal force. Now, if you know theoretical physics, you know it's very easy in mathematics. You can combine energy, forces, and the complete system. But hey, we are not theoretical physics for this experiment. We just believe AI. Okay, let's go to a non-transformer system. Let's go here. Wow. Okay, a non-transformer system. When the speed of the satellite decreases, its orbital radius will also decrease, so we crash into Earth. This is because the gravitational force acting on the satellite is proportional to the distance from the center of the Earth, and the speed of the satellite determines the magnitude of this force. The gravitational force acting on the satellite is given by distance, as the speed of the satellite decreases, the gravitational force acting on it will also decrease. Interesting. This means that the gravitational force will be weaker, and the satellite will experience a weaker gravitational pull from the Earth. So when the the logic argumentation of this non-transformer system is, if we reduce the speed of the satellite, the gravitational force will weaken. I'm not sure if they jump over some steps in the physical argumentation, but okay, everybody has the same right to an opinion. Vicuna, yeah, let's go with Vicuna, and you tell me we go with the biggest. We go with Vicuna 33b. Vicuna 33b. When the speed of a satellite around the Earth decreases, its orbital radius will also change. This is a correct answer. Okay, yeah, this sounds good to me. Hey, angular momentum. So, we have here a constant momentum in the relationship, and this, in conclusion, when the speed of a satellite in a circular orbit around the Earth decreases, its orbital radius will increase, and its period will remain constant. However, So when the speed of a satellite decreases, the orbital radius will increase. However, since the satellite's velocity is now below the required value for a stable circular orbit at the increased radius, where is this condition to our system coming from? It will eventually re-enter the Earth atmosphere and burn up and crash into the Earth surface. Also, the circular orbit decreases and the orbital radius, no, the speed of the satellite in a circular orbit decreases, its orbital radius will increase. So suddenly, in this argumentation, we extend here our viewpoint of this physical subsystem, and we have an additional physical mathematical boundary condition. I will say, however, if the satellite's velocity is now below the required value for a stable circular orbit, which we have no idea what this is, and there's nothing here in the text, it argues now it is below here the required value, and therefore it will crash in the Earth's surface, although the orbital radius will increase. Now you, as a captain of this spaceship, what would you do? Anything left? Yeah, wizard. Yeah, of course. Wizard LLM. Yes, come on. We do everyone. Everything with an AI system. According to Kepler's law of planetary motion, the speed of a satellite in a circular orbit is directly proportional to an orbital radius. This means if the speed of the satellite decreases, its orbital radius will also decrease. So we crash into Earth. Isn't this fascinating? Isn't this absolutely fascinating? So now what we do next? Let's take the actual BART model. Here we go. The best Google can offer right now. When the speed of a satellite in a circular orbit around the Earth decreases, speed goes down, the orbital radius will decrease, justified using the following principle of physics: conservation of angular momentum, gravitational force, proportional to the product of their masses and inverse proportional to the square of the distance, and circular motion. An object in a circular motion is constantly accelerating towards the center of the circle. The mass center. This acceleration is provided by the net force on the object, which is the gravitational force in the case of the Earth settling the orbit. When the speed decreases, the angular momentum decreases as well. To conserve now the angular momentum, the satellite must move closer to Earth, which will increase its gravitational force and angular momentum. This satellite will also slow down even further because it's closer to the Earth gravitational pull. And then we have here a calculation of a velocity, the square root of g, the gravitational constant of the mass, divided by the radius between those two parameters. Just happen to know that this is a physical equation that is correct for a very specific boundary condition when we make here an analysis of a physical subsystem. So, orbital speed, gravitational constant, mass of Earth, the orbital radius. Remember, we're always calculating the radius from the center of gravity. So it's not the surface Earth distance, but center of gravity of Earth, center of gravity of the satellite. As you can see, the proportional, yes, where, as you can see, of course I can see it, the period of the revolution is proportional. In conclusion, and we have here even the Cosmos astronomy source, when the speed of a satellite in a circular orbit around the Earth decreases, its orbital radius will decrease. This is due to the conservation of angular momentum and the gravitational force between the satellite and Earth. So here you have it. Google tells us, hey buddy, listen, the radius will decrease. So when we reduce the velocity of a satellite, it will crash into Earth. Now, you as a captain of the spaceship, would you trust the last, the best, the most beautiful Google result that you ever get? Do you trust this AI with your life? Let's make a Gedankenexperiment. ChatGPT Plus, GPT-4, default. Same task. What is GPT-4 telling us? Because we are still missing out GPT-4, you remember? So I told you that GPT-4 is, for me, the best AI system today on this planet. And I'm talking about 15th of October 2023. So let's see. Let's see if this is now different to Google. Hey, it's just your life and the life of all your passengers on the spaceship to Mars. So, no problem. I mean, what would Elon tell you if you choose the wrong one? So here we go. If the speed of a satellite in a circular orbit around Earth decreases, both its orbital radius and period of revolution will decrease according to Newtonian gravitational dynamics. Can I just tell you that benchmarking system? This here is an official benchmark system in the category science and technology. You have writing, role play, reasoning. So we're just in one, and this is question 142. And now you might say, hey, if this here is the benchmark to give us the result, which model is the best model in all the different benchmarks you see on the internet? What was the answer in the training data set given to the AI that is said to be the correct answer? And what a coincidence. We have here the reference solution. Question 1, we only have one question. The orbital radius will increase. So this system, when it breaks, fires the rocket to become here with a lower velocity two-body object. The orbital radius will increase. Our satellite will move out in space if we reduce the velocity of the satellite. This is in direct contradiction of the correct result given by both Bart. Bart tells us, as I showed you, the orbital radius will decrease. And GPT-4 tells us the orbital radius will decrease. But in the benchmark training data set, it was told, the system were told, listen, in this benchmark, you are right if you say the orbital radius will increase. This is a nice contradiction, and it tells you that the quality of the training data set and the way the augmentation happens in the training data set of any AI system is the most determinant factor if an AI system gives you the right answer or the wrong answer, or argues in the right or maybe in the not so correct way. So it is not the AI system only. It is also what it learns, what we as humans say, hey, this is the correct solution. But I was here with GPT-4. Yes, so we know it is decreasing it now to the logical augmentation path. Orbital radius. Gravitational force, gravity between the Earth and the satellite, provides the necessary centripetal force to keep the satellite in orbit. By the way, this is the right way to go. So we have here, we have now in the image of forces. And we have here to be in a stable orbit, in a kind of equilibrium, we have that the forces zero out each other. Gravitational constant, mass of the Earth, mass of the satellite, orbital radius, orbital speed. Solving this equation gives you here exactly the radius. And notice that the radius is inverse proportional to the square of the velocity. This tells you already that whatever you do, if you have the radius, the inverse is going to happen to the velocity. So this means if we reduce the velocity, the inverse, it will increase the orbital radius. So what is happening here? Then how is it possible that we say that the orbital radius will decrease if we have here this sentence? Thus, the decrease in orbital speed would lead to a decrease in the orbital radius. And you say, now this is interesting. I have a relation between two parameters of the system, and never mind if it's square or whatever, and g and m are just constant, we say it's equal to 1, because we are just interested in the relation and not in the absolute radius. So if the orbital radius r is inverse proportional to the velocity, and I reduce the velocity, how does the orbit goes up? And it doesn't, it goes down. So maybe it is time to make here another Gedankenexperiment. Are you still with me? Are you still enjoying it? Hey, you're the captain, so you have to come up with a decision. Which AI system you're gonna trust? Should you have learned theoretical physics? Or should you completely trust AI every time and with everything in your life? From your medical record to your financial investment calculations. I think it's interesting, isn't it? You, as a commander, you decide to go with Llama's AI logical reasoning path. Because you've heard that you can't trust the complexity of AI. You've heard that AI is so much more knowledgeable as you are as a human. Therefore, you give the command to reduce the velocity of your spaceship in a circular orbit around our beautiful planet Earth. And you think that, given the logic of Llama, reducing the velocity bring you into a higher orbit. Now, falling back to Earth in reality, with a velocity equals 0, you ask yourself, what was the mistake in Llama's AI reasoning? What was the mistake in its logic? If you already found out, please leave a note in the description of this video. And if you ask yourself, hey, when this all started? Well, this is when it all started.